Hi, my name is Justin Canna, Engineering Specialist for AIChE, and today I will be interviewing Jose Tabora, Research Fellow at Bristol Myers Squibb. My guest today is one of the speakers for the Pharma 4.0 session in the Next Gen Manufacturing Topical Conference. He'll be giving a talk at this year's annual meeting titled Approaches to Knowledge Management and Data Transformation in Pharmaceutical Process Invention. Thank you for joining us, Jose.
Well, thank you, Justin. Glad to be here.
To get things started, could you tell us what are the most striking changes in data science as it is applied to small molecule product development that you've experienced?
Sure. So I've been in the industry for 25 years, and I started fresh from grad school. And at the time, we were using paper notebooks. So everything was written, a lot of the data was analyzed by hand, the graphs were done by hand. Reports were typed. So eventually we migrated towards electronic notebooks, which now the data is captured digitally, still hand enter. And at the moment we're getting close to having the instruments enter the data digitally. And I think what that's been doing progressively is we have become more sophisticated about modeling, more sophisticated about data science, and I think that is going to increase as we move into the future.
In your talk, you mentioned that chemical engineers can contribute to innovation in this field. Why do you think that their particular skill set fits in here so well?
Yes, I think chemical engineers have the right balance between having mathematical curiosity, but also curiosity about the physical sciences. So they can acquire very readily the skills that are necessary to perform data science and to get the right insights. One of the dynamic tensions that I see in many organizations is there's a tendency and an inclination to create a data science group of experts that supports the general scientists. I think in the case of chemical engineers that is not necessary. It is far more productive to have the chemical engineers on their own acquire the data science skill set and apply it themselves.
Where do you see the future of this field heading? And what aspects do you think are going to change the most?
Well, I think the software is getting more sophisticated. There's more, it's also getting more accessible. Most of the tools that we use now, we went from using known to using tools that have licenses and were fairly expensive. Now, a lot of those tools are open source. A lot of the applications within those tools are also open source. I think the main change in data science is not going to happen so much at the data scientist level. It's going to happen at the point of collecting the experiments. I think it's going to be fairly important that the scientists that are collecting the data, collecting the experimental data, are more aware that there's a broader need than just their local individual question that they want to answer with that experiment, that their experiments really belong to the larger organization and that can be far more useful if they are contextualized in a way that they can be utilized broadly.
Wow, that's great. I'd like to thank you very much for coming by and speaking with me.
Oh, thank you.
And I guess, do you have any words of wisdom for our younger colleagues?
Well, I'm not sure if it's wisdom necessarily, but one observation that I made through the years is the people that I've seen that have become very successful weren't afraid of new experiences. I think one possible mistake that younger scientists can take is to have a very rigid view of what their career is going to be and how it's going to progress, as opposed to being open to experiences. I don't think that, personally, I don't think that any of the experiences that I've had I regret or I have not been able to utilize throughout my career.
Thank you very much.
Well, thank you, Justin. It was a pleasure.